Hey everyone, this video is going to explain the multiple representations of linear functions target on the review. So in this scenario, we've got Rapunzel's hair and it's growing like crazy. So Rapunzel begins keeping track of the length of her hair after her last haircut, and she sees that after 5 weeks it's 60 inches long, and after 8 weeks it's 75 inches long. So first off, we're going to complete the table. So we know that after 5 weeks it's 60 inches long. So when x is 5 for number of weeks since last haircut, y is going to be 60 inches. We also know after 8 weeks it's 75. Well, let's figure out then, what is that growth? I'm not sure. Well, there's a couple different ways you could do this. You don't have to start with the table. We could look at the graph first. We could look at the equation first. So if you want to look at the table first, you need to figure out what is this growth. So if it's growing by after 3 weeks of x growth, the y value, the inches, are growing by 15 inches. So you know that our change in y over our change in x is our slope, right? So we're saying 15 divided by 3 is our slope. So our slope is going to be 15 divided by 3. So every week it's going 5 inches up. So we see that week 5 it's 60, week 6 would be 65, week 7 it would be 70. So then we can fill in the rest of the table. 55, 50, 45, 40, 35. So it looks like it was 35 inches when she last got her haircut. So now we're going to graph it. And we want to provide a scale on both axes. That means we need to label the axes. So what would be a good thing for our x's to go up by? Well, I just say let's go up by 1. So that seems like it would make sense. 1, 2, 3, 4, 5, 6. I'm just finishing labeling these. 16, 17, 18. Then our y's, it's going up by, well, it would make sense. Maybe go up by 5s. I don't know. I feel like that would make sense. We need to be able to show all the way up to 75 inches on here. So let's see if that'll work. What if we go by 5? 5, 10, 15, 20. $75, 80, 85. Should be perfect. So, actually, that's not gonna show enough growth, right? That's only gonna show us all the way up until 8 weeks. So I'm gonna go something a little bit bigger. Let's do 10s instead. Let's do 10. Sometimes you just gotta trial and error, see what makes sense. $110, $120, $130, $140, $150, $160. This would be really long hair. But Rapunzel does have really long hair. So we have it scaled. Now let's graph it. Let's graph some of these points. We know at 0 it's going to be at 35 inches. Then at 1 it's at 40, 45, 50, 55, 60, 65, 70, 75, 80. Well, you know, we could keep going, or we can now just draw that line. We can say keeps going. And there's our graph. Make sure to be really specific. If you need to, draw in those slope triangles. Draw that over the course of 2 weeks, it goes up 10 inches. 2 weeks, 10 inches. Or you could even do every one, but that's kind of a small triangle. So you could say 2 weeks, 10 inches. So now we're creating an equation. Well, we know, luckily, since we did the table first, we have all the information we need. We have our slope is 5, and our y-intercept we have is 35. So we could just write our equation knowing that m equals 5 and b equals 35. So we know our equation's y equals 5x plus 35. But also, if we want to, say we didn't want to start with our table. What if we wanted to we were just given our original info and we wanted to start with the equation right away? Some people might like to do that instead. Let me just show you how you would want to do that. Well, we were given that after 5 weeks, it was 60 inches long. After 8 weeks, it was 75 inches long. So one way we could do is using that glorious method, using 2 points to solve. You could say 75 minus 60, ry minus ry, over 8 minus 5, x minus x. That's kind of what we did when we solved in the table anyways, because we get 15 divided by 3 equals 5 for our slope. And then if we have our slope, if we didn't have our y-intercept from the table, we can use any of our points that we have to solve. So we could say that y equals 5x plus b, and then we can plug in either 5, 60 or 875 for x and y. So I'm going to pick 5, 60, and I could write that down here as 60, which is our y, equals 5 times 5 plus b. Well, 60 equals 25 plus b. If we subtract 25 from both sides, we get that 35 equals b. So that was another way you could get m, our slope, and b, our y-intercept, if you wanted to do it using algebra and using those points instead of starting with the table. But either way, you get our equation, y equals 5x plus 35. And then finally, D says, how long will Rapunzel's hair be after 17 weeks? And we want to show how we found our answer using at least 2 representations. So one way I'm going to use is the equation. I think that's always one of the most straightforward ways. So we want to figure out how long her hair is. We're trying to find our y after 17 weeks, which is our x. So we could use our equation and say y equals 5 times 17 plus 35. Well, 5 times 17, let me just get out my calculator, is 85 plus 35. So y is going to be 120. So it's going to be 120 inches after 17 weeks. Which is actually what? 10 feet long? That's pretty long hair. But we also want to show at least 2 representations. So we need to use a second one. So we could also continue our table. You know, we have our table going. You guys, the last one we had was 875, so we could keep going. We could say 9, 10, 11, 12, 13, 14, 15, 17. And just keep it. 80, 85, 90, 95, 100, 105, 110, 115, 120. We also could show, you have to make sure you would actually show this correctly on your graph, that you have it accurate. But you could show that over at 17 weeks, if you look up here at my graph, we got 17 weeks. It's over at 120 inches. So you'd want to make sure to be clear and label this in the graph. You'd say that at 17 weeks, 120 inches. And you could label that point, 17, 120. So if you're going to use our graph as a justification, make sure you show that and you explain using pictures and writing, not just point at the graph.